Okay, so we'll take a look at two more electromagnetics questions. So the first one here is, what is the difference between a step-up and a step-down transformer? So these are definitions that you have to essentially memorize, because sometimes you'll have questions that tell you something is step-up or step-down, and from that you have to infer something. A step-up transformer essentially raises the voltage. So the voltage coming in is less than the voltage going out. This is what we call step up. A step down, on the other hand, so the opposite of a step up, a step down transformer, the voltage in is actually going to be greater. Sorry, not current, the voltage. Voltage in is actually going to be greater than the voltage out. Typically, when you have a power station will connect to a step up transformer so that you can get really high voltages across power lines, like 400,000 volts, and then after the power has traveled really long distances, it will go to another transformer which will step it back down. Right? So the power plant will produce it at 1000 volts or whatever. We use it at 240 volts in our house. It has to be stepped up first to travel, then stepped down when it gets to us. So this is the difference between step up and step down. We're asked another question. We are asked, why is an AC current necessary for a transformer? Okay, so this is essentially, there is a definition which is true for this answer. It's an AC current is necessary to induce a flux, changing flux in the iron ring. So in order to induce an EMF, so to induce an EMF on the secondary coil, you need a changing flux. Right? And this would not happen with a DC current connection. If you had a DC current coming in, the flux would stay the same. Right? If you have an AC current coming in, it constantly oscillates back and forth. And so that means that the flux constantly changes back and forth. This change in flux induces the current on the output side. So this is the definitional answer to the second question here.